In the second part of today's lesson, we're still going to be looking at solving rational equations, but this time by using the least common denominator. So the first thing on these is to know that this is a type that you're going to use when you don't have a fraction equal to another fraction. You're going to have more than one fraction or more than one term on at least one of the two sides of the equation. So when using the least common denominator method, the first thing you're going to do is factor all denominators. And then you're going to multiply each term of the equation by the different factors in the denominator. So make sure that you only multiply by each factor once. It's going to make the problem a lot simpler if you're only multiplying by each factor one time. So let's now look at an example where we're going to use the least common denominators method. This is example 2, and it's an example of learning target 5.6b. So they want us to find the solution of 15 over x plus 4/5 equals 7 over x. So the least common denominator method, what we do is we multiply each term by the denominators to cancel out those denominators so we won't have fractions. So when looking at this problem, we're going to look at our denominators. If I start with the first denominator, I have an x. So I'm going to multiply each term by an x. So I multiply all three of those terms by x. My second fraction has a 5 on the bottom, so I'm going to multiply all three terms by a 5. And then the third fraction has an x on the bottom again, and I've already multiplied by x, so I'm not going to multiply again because I don't want to double up because that's going to then make the problem a little bit harder. So now that I've multiplied by everything that I have, I go ahead and cancel out those denominators. So for the first term, the x is going to cancel. The second one, the 5 is going to cancel. And then the third one, the x is going to cancel again. So you see now that by doing this, I've now canceled all the denominators. So then I write out the problem. I have 15 times 5 plus 4 times x equals 7 times 5. So now to simplify this, 15 times 5 is 75. So I have 75 plus 4x equals 35. And then I solve from here. So I subtract the 75. I get 4x equals negative 40. And then I divide by 4, so x equals negative 10. And there is my answer. So now let's look at another example where we have to use this least common denominator method. This is example 3, and again, learning target 5.6b. So they want us to solve the equation 12 over x plus 7 equals 1 minus 12 over x. Again, the very first step is always to factor the denominator, like on the last one. The last one didn't need any factoring. This one also, when I look at the denominators, I have linear factors, so I don't need to multiply, or I don't need to factor the denominators. So now I'm going to go ahead and multiply. So my first fraction is an x plus 7. So I need to multiply everything by an x plus 7. And there are, again, 3 terms. So I need to make sure to multiply all 3 of those terms by the x plus 7. My second term now is just a 1, so it's a whole number. So really, if I write it as a fraction, it's like over 1. But because it is over 1, we don't need to multiply by that, because multiplying by 1 doesn't do anything for us. And then the third one is an x. Now the first thing I multiplied by was an x plus 7. This is an x. Those are 2 different terms, so I do need to now multiply everything by an x. So I'm going to multiply all 3 of those terms again by, in this case, an x. And now that I've multiplied by all my denominators, I'm going to go ahead and cancel. So for the first term, I cancel out the x plus 7s. Second term, again, there's no fraction, so there's nothing to cancel. And then the third term cancels the x. So now let's rewrite our problem so we can see what we have left. For the first term, or the left side of the equation, we have 12x, and then that equals 1 times x plus 9. So I just have the x plus 9 minus 12 times x plus 7. And now again, there are no denominators, so it just becomes a regular algebraic equation to solve. So let's go ahead and solve it. So the first thing we need to do is distribute to get rid of our parentheses. So 12x equals x squared plus 9x minus 12x minus 84. And since there is an x squared, we need to get everything on one side. So I'm going to subtract this 12x over, so I get 0 equals. And in that same process, I'm going to combine all my like terms. So I have 9x's minus the 12x's, then minus another 12x's from the left side, giving me minus 17x, and then minus the 84. So now I want to solve that. So I want to first try to factor. So I want to try and find numbers that multiply to be a negative 84, that when I add them together will give me negative 17. So in this case, I know that I could do a negative 21 times 4. When I multiply those, that will give me a negative 84. When I add them, I do get the negative 17. So to finish factoring, I then have x minus 21 and then x plus 4. Now set each of those equal to 0. So x minus 21 equals 0 and x plus 4 equals 0. So x is equal to 21 and x is equal to negative 4. And those are my answers to this problem. There's one more thing we need to look at when solving these rational equations, and that is what is called extraneous solutions. And we've worked with these extraneous solutions before, but they're also found in some rational equations. And remember, an extraneous solution is a solution to a resulting equation, so an equation that you get within the problem, but that is not actually a solution to the original. So even though it works out maybe algebraically that it should be a solution, when you plug it back into the original, and that's the key here, that you've got to plug it back into the original equation. So when you plug it back into the original equation, it does not work. So the key here is always to make sure that you check your answers. So once you get an answer, double check by plugging it back in to make sure that it does work. So you want to make sure that you're checking your answers to these problems. Let's now look at example 4, again learning target 5.6b. So they want us to check or to solve and check for extraneous solutions. And our original equation is 7 over x minus 1 minus 5 equals 6 over x squared minus 1. So remember, the first step always, even though we haven't had to do the first step, is to factor the denominators. When looking at the first term, I see that I have just an x minus 1. So that is linear, so there's no factoring on the first term. The second term is just a constant of 5, so again that's like a 1 in the denominator, so we're good there. But the third one has an x squared minus 1. And we know from working with differences squares that x squared minus 1 factors to x plus 1, x minus 1. So that takes the place of what was in the denominator. So now I have them in factored form, so now I can go ahead and multiply to get rid of my denominators. So the first one starts with an x minus 1. So I'm going to multiply each term by an x minus 1. Then the second term again is a constant, so there's a whole number, so there's no fraction, nothing to multiply by. And the third one has that x minus 1, and it has an x plus 1. So since the only thing that it's missing, since I've already multiplied everything by an x minus 1, I don't want to multiply by that again. So I am going to multiply by the x plus 1. So take all three terms by the x plus 1. So now what I've multiplied by is what is actually that least common denominator. That's why we call it the least common denominator method. But I've multiplied by every factor that can be found in any of the denominators. Again, you never want to repeat any factors because then it just makes the problem more complicated. So now that I have multiplied by everything that's in the denominator, I can start canceling. The first term has the x minus 1 in the denominator. It cancels with the x minus 1 that I multiplied by. The second term, there is no denominator, so nothing to cancel. third term, I have an x plus 1, so it cancels, and I have an x minus 1, so it also cancels. So now looking at what is left, first term, I've got a 7 times an x plus 1 minus the 5 times the x minus 1, x plus 1, and then that equals 6. Again, it got rid of our fractions, so now it's just an algebraic problem we need to solve. So I'm going to start by distributing my 7. So I get 7x plus 7 minus 5, and then my quantity of x minus 1, x plus 1 becomes x squared minus 1 equals 6. And one more distributing, so 7x plus 7 equals, not equals, minus 5x squared plus 5 equals 6. Again, there is an x squared, so I want to get everything on one side. I'm actually going to move it to the right so my x squared becomes positive. So I have a lot to move then. So 0 equals 5x squared. I have on the left side 7 x's, so I'm going to pull it over and subtract it over and make it 7x. On the left, I have a 7 plus a 5, so that's 12, but then subtract it over, so 6 minus 12 is a negative 6. So I've got 5x squared minus 7x minus 6. So now I need to factor that. So remember, factoring when there's a leading coefficient says I take the first times the last, so 5 times negative 6 gives me negative 30. I want numbers that are going to multiply to be a negative 30 that add together to be a positive, or a negative 7, sorry. So in that case it would be a negative 10 and a positive 3. So now I need to finish factoring that. I'm going to come up here where I have a little more room. So I've got 5x squared minus 10x plus 3x minus 6. So now I can factor by grouping, so I split it in half. Out of the first half of 5x comes out, leaving an x minus 2. Out of the second half, a 3 comes out, leaving an x minus 2. So now I have that x minus 2 in common, so I factor it out, leaving the 5x and then a positive 3, so plus 3. Now keep in mind that was still equal to 0, so I can now set each part equal to 0. So x minus 2 equals 0, 5x plus 3 equals 0. So for the first part, I get x is equal to 2. For the second, I subtract the 3, giving me 5x equals a negative 3. Divide by 5 gives me a negative 3/5. And now I take those answers, plug them back into the original just to double check to make sure. A lot of times what ends up happening is it's the denominators you need to watch. So just make sure that you're not getting a 0 in the denominator. And for both of these, neither would give me that. So both of these, and when plugging them into the original to double check, I do see that I do get 2 true statements. So I have answers of 2 and negative 3/5. So now let's look at one more problem, solving this by the second method. So learning target 5.6b. And I want us to solve 5x over x minus 2 equals 7 plus 10 minus x. So I'm going to multiply first the factor, and looking at my denominators I see that I only have linear factors. So I'm going to go ahead and just multiply now by those linear factors. The first fraction has an x minus 2, so I'm going to put that with each of my terms. Second fraction, or second term, is not a fraction, so I don't need to multiply by anything. And then the third term, or my third fraction, has an x minus 2 in the denominator. I've already multiplied by that x minus 2, so I'm not going to multiply by the x minus 2 again. So now I'm going to cancel, so the first one's cancel. Nothing cancels in my second term, and then the third term, the x minus 2 is also going to cancel. So then what I have left is just a 5x equals 7 times the quantity of x minus 2 equals, no, not equals, plus the 10. So now distribute the 7. So 5x equals 7x minus 14 plus 10. Combine some like terms. So 5x equals 7x minus 4. And now get our x's together, so I'm going to subtract that 7x over, giving me negative 2x equals negative 4. Now divide by 2, so I get x equals 2. So now before I circle it to say that it is my answer, I do need to plug it back into the original equation to make sure that it works. When doing that, I see that on the bottom of the first fraction, I have an x minus 2. When I put an 2 in for that, I get 2 minus 2 or 0. And it's not possible to divide by 0, so that means that this x minus 2 does not work. Since it is the only answer, that means that my overall answer is no solution. So it is possible to get a no solution for these problems. It's also possible to get maybe 2 possible answers, but then when plugging it back into check, only one of them works. And then like we saw in the last example, it is possible for both of them to work. So you just always got to make sure that you're checking to make sure that you're getting the correct answers.